Hello. All right. How's it going? Good. Excellent. All right. I've almost gotten the two groups synchronized so that my teaching is no longer a nightmare trying to figure out what I taught to who. That's the good news. Because you guys learned some stuff they didn't, and they were learning stuff you guys didn't, so I kind of flipped the stuff around. What I'm going to do today is one part review, which there might be new terminology in there that you haven't seen. And I'm sorry calling it a review, but it might not be a review. And I'm going to cover aggregates again because there's terminology involved with this that shows up on the exams and tests and stuff that might not have been used with you guys. And I'm going to cover subqueries also, which is where my guys just finished on Monday. So by this point, we theoretically are almost at the same point. Theoretically. Assuming you at least maybe watched 2 of the 4 videos I posted or watched the other videos I've been recording with you guys. Let's make sure this actually still is recorded. Yes. That's always good. Okay. And when I'm going to review terminology, I'm going right back to the basic concepts. Just to make sure that we're all working with the same words. And when it's time to be ready for the final exam, we are talking all on the same words. And I'm going to start way back. Okay. Let's see how much my camera freaks out over the bright light. It's going to work. We're good. All right. Okay, hopefully we know what this is by now. Database. It's a collection of information. Okay, we're all talking the same language. I want to make sure we're all talking the same language. A database is made up of what? Tables. Data and tables. It's made up of data. Oh, we're going to have that kind of writing day, aren't we? Okay, and this data is organized how? And now I'm going to put down 2 columns. Because it's organized in 2 different kinds of things, and that doesn't come out. All right. Data is organized in design, it's organized in entities. In the physical design, it's organized in tables. And by the way, I misspelled organized.
Entities.
Hey? Oh. Oh, boy, damn. I should have had some more coffee before I came in. Okay. It's organized. I'll be a teacher and go, there's an A that goes here. And so database made up of data, it's organized in entities and tables. Okay, the details are known as either attributes and or fields. They mean the same thing. Or columns. Okay, so tables and entities is interchangeable. Attributes and fields is interchangeable. But when you're talking about just the design side, it's this word. When you're talking about the physical side, it's this word. Now, you have data types, and when you talk about the data types, when in the design world you use the primitives. You guys know what a primitive data type is?
Yes.
It's text, it's a number, it's a date. Those are primitive. Whereas when you're talking physical, you're using precise types. For example, you have varchar, integer, timestamp. Those are precise data types. As in, you're identifying specifically what kind of data type it is. It can have limits. Such as a numeric, where you set the size and the precision. And depending what design software you use, the word precision changes what side of the comma it's at. Toad puts the word precision on the left. Other ones put it on the right of the comma. Okay. These are the little bits and pieces, the basics of what a table is. Now, what do you use to identify a row uniquely? Well, the field name identifies the column name.
The ID.
The ID, which is also known as a?
Identifier.
All right. And this is where terminology gets dumb. In the design world, the primary key is actually called a prime key. And that's not how you write the word key. In the physical side, it's a primary key. More and more, primary keys being accepted on both sides of that line. But up till a few years ago, prime was when you were doing the design. When you started doing the physical, it became the primary key. By the way, primary key is the word that's supposed to show up on the exam. We just finished negotiating terminology for the exam. So, but you just should know that in case primary key doesn't get replaced ever in the exam, the word prime key might show up. They mean the same thing. Okay? All right. So these are the basic pieces of terminology when you talk about databases. Now there's just a few others. And I'm going to go onto that board over here. I'm just going to make a note here what I'm covering. I forgot the other word. And that's the word. There's also we have the basic relationships. And the relationships have several kinds of notation out there. Specifically, we've been sticking to crow's foot for this program. There's actually 8 kinds of notation for database that all achieve the same goal. It's just everybody needed a different notation for their PhD. The crow's foot is the most commonly recognized one. Now, and there's the cardinal relationship and then cardinality. Now, the type of relationships we can see one-to-one. That means one table is directly related to another table, and there's only ever one of each. You got one to many. So that's 1 to 1, 1 to many, and then you got many to many, Okay. So you got one-to-one, one-to-many, many-to-many. These are the three common relationships. There's also one last one, which is, it doesn't have this kind of code. It's known as a self. It's a self-referring. In other words, it's a table that refers to itself. When you try to do structured data such as trees, lists, that kind of stuff, you can actually have it as that kind of structure. So that's our common 4 types of relationships. And actually, I'm going to skip cardinality for the moment, and I'm going to put up my good old the design versus the physical side of it again. Okay. The crow's foot notation. Actually, I want to make sure the camera's grabbing all of it. Yeah, good enough. 1-to-1. Normally, you end up with a line that looks like this. 1-to-1. That means that there's 1 and 1 on each side. I haven't touched the cardinality yet. Physical. It actually has the exact same picture. So if you're doing a logical ERD, it's these symbols. If you're doing a physical ERD, it's this symbol. One-to-many, again, they look the same so far. Then you got many-to-many. It looks like this. So you got many-to-many. And on the physical side, many-to-many has been frowned upon for years. Like, you shouldn't do this anymore because it's bad. What they've done instead is you should be using something called an associative entity, which I will draw in a moment. And then you got the self-referring, which is always kind of funny looking because it goes back to itself. And in the physical, it's the same. So you can see most of the symbols are the same, except for the associative entity. The associative entity is something like this. Come on. I haven't gotten it right once in the last while. Customers and groups. What ends up happening, you have an ID, you have some other fields in here. Now, if I was doing this as a logical diagram, really? That's why they left their markers, they're both dead. Think I'll get the second one right? Oh, it bounced off the back. All right, so the logical, which is this guy, would have done this. However, this is sort of frowned upon now. What the preferred approach is what they call an associative entity, which is a table in the middle that is made up of the primary keys of the other 2 tables. So you go ID and group ID. And then we get rid of this. So when you're looking at a logical design, this is how you represent many-to-many. When you do a physical design, like in Toad, you do it like this. Code has a special tool to do it. You might not have noticed it, but in the toolbar at the top, there's one called many to many. And if you click on that, and you click on the first table, second table, it actually creates the middle table for you automatically. And this is how a physical ERD looks like for an associative entity. All right. We have one last bit that has to do with this side of the theory, and it's cardinality. Cardinality implies whether or not something is required, whether or not something is not required, I guess. And the way the symbols for that work, am I good nuking this board? Okay. Cardinality. And again, you've got a design. And a physical aspect to it. When it's in the design, you end up using words. As many. Must have. I'll start with those two. Last one's hard to word. So on the physical side, on the other hand, though, you have the symbols as follows. So this is, one to many, or semblance of one to many. The cardinality adds a second symbol on the line. And the symbols are required. That means it must be there. The other one we have is the circle. Circle means 0 or more. It means that the child is optional. In this case. You can also have the 0 over here. This means parent optional. That's a type of relationship I've almost never used. Unless I've had a client that argued with wanting it, I try not to use that because it's really easy to have orphans. The required works the same way on the other side, where in theory you can have a relationship that looks like this. Which means you can have records in either table and they're optional, the related records optional. Or you can have where one record cannot exist unless there's another record. Those are the two sets that you'll see. Both must exist. That's both parent and child is optional. All right. That should bring us technically to the theory side of terminology-wise. That's all the different terminology that you would have seen so far in the various lectures in the textbooks in chapters 2 and 4. And you guys have already been doing stuff from 6 and 7. Congratulations, you're ahead of my guys. Actually, they're catching up to you in a hurry. I'm pushing them a little harder too now, trying to get everybody synchronized, so they're suffering also. And so what's happened now is we've covered basically chapters 2 and 4 in terminology-wise. You will want to review those chapters, definitely for the exam, just putting it out. So you don't have to worry about chapter 1. Actually, I should take pictures of this. It's probably the best written version of this I've ever done on the board. I've been practicing my handwriting for you guys, because my handwriting sucks so bad. That's 1. It's 2. Okay. All right. So the next thing I'm going to do is, and I was going to do a little bit of review on the SQL side of the deal, about some of the things that apparently I was taking for granted, because this used to be a level 2 course. And I was saying things to my other students, and they're like, we have no idea what you're talking about, after complaining in lab to me. So, so have you guys started tackling my Lab 8 yet? My version of Lab 8? Yeah. Okay, so you've probably hit a few bit of terminology in there that you might not have heard, or you might not have heard used that way. That's the difference between somebody who writes labs that works in the field and people that write labs for education. Right? It's a slightly different. So this over here. There. All right. I'm not going over the basic select statement. I think we've got that covered. But there's some things that some people aren't aware of, some SQL side. Whereas you guys by now probably know how to select star from whatever. I hope you do by now. If you don't, okay. Because I think that sounds like pretty much what you guys started with in lab. Now you guys have covered joins with me last week. So I'm not going to cover that too much because it's the same level you're at the same level as the other guys. However, there's a few things. I'm going to talk about what happens after the table selection, the where clause. And believe it or not, the biggest problem I've noticed with my guys is they don't know what the logical operators are. They're a little confused about what the logical operators are.
They're not taking Java?
They are. But, okay, we know this is equals, right? And then we have greater than and less than. Okay, good enough. Now we have greater than or equal. Okay, that's we know. And we have, wow, that's an awesome less than sign. Less than or equal. And then there's good old SQL being slightly bipolar. You have the choice of two different versions of non-equal.
The first one's kind of been deprecated, the last one.
No.
No?
Yes and no.
Okay.
It's never going away.
Oh.
Why? Because this is actually what's in the standard
Oh.
originally. They added this because the C++ and Java guys couldn't figure out what this meant. They understood all of these, but the programmers didn't understand that this was equal to this, so they decided, we'll just add it to the standard to make everybody happy. You will see tons of examples of this on the internet. It's still around, it's still in use. I still use it because my brain's wired that way. I'm trying to get used to doing this so I don't confuse people. Okay, those are the standard operators. Now we have a few other things that exist. There's one called in. You guys have been taught about in? Okay. In a list, which is also known as a vector. It's a list of values. Same thing. Okay? For now, I'll take the word vector off. It's in a list. There's also between. Between is shorthand, right? You've got between 1 and 5. This is an inclusive function. In other words, this is the whole inclusive-exclusive question where apparently people are having a hard time, at least in my section, we're asking the concept of inclusive and exclusive. So I've got 1, 2, 3, 4, 5, 6. This is inclusive. So when somebody asks you for a range of information that is exclusive, they don't want the inputs, the end values. If you want to do inclusive, you include the end values in it. So between is inclusive. Between works with numbers, text, and dates. In other words, it works with all data types. It doesn't work with Booleans. Between true and false. There's only, yeah, I'm not even going there. How about that one? Those are the two other operators that you see most often. There's a few others, but these are the big ones. In and between. When there's also a modifier for in and between. And what's the modifier called? Pardon? Anybody? Not. Gives you the inverse of these guys. So if you have a list of 2, 3, 4, and you go not 2, 3, 4, it gives you everything but 2, 3, and 4. It inverts the selection. Which leads us to the next step, which is the things that allow you to use more than one clause. And what are the two keywords that let you use more than one clause? Okay. Those are the two. And I got to refresh myself on something really quick. Where are we? Oh, no. That's not cool. Looking for something really quick. And I can't find it off the top of my head. I will get back to you guys on what I was about to add because I can't remember off the top of my head exactly which one what order it happens in. But I do know for a fact, not and an or, if I remember, it gets processed in the order of not, and then or. But I'm not 100% sure. So I will send out an email tomorrow to everybody. So if I got it wrong, I'll actually put it on the video and say Dan's wrong here. Because I can't remember off the top of my head which order it goes in. And of course I was trying to flip through the textbook really fast and I can't find it in there either. But apparently it's in there somewhere.
That's correct.
It is the correct one?
Yeah.
Oh, good, thanks. What page on the textbook was that? Oh, you don't have real page numbers. All right, yes, it's not and an or. Thank you. I thought that's what it was, but I wasn't 100% sure off the top of my head. All right, so that's the order of that the different operators happen in. Now, the old way of writing between would have been something like this. Like that, which they've now shorthanded down to, if I were to write it here, the same way would be between 2 and 5. That's the shorthand version of this. Obviously, if you want to make it exclusive, you just do this. Get rid of the equal sign, now it's exclusive. Now, also you got to remember, brackets are processed first, just like in algebra. So it resolves the contents of the bracket first, and then it steps out and resolves the rest of the clause. So if you need to do an or then an and, you put in clause 1 or clause 2 inside of brackets, then you do and the third value. Okay. That's the basic terminology on the outside of the where clause. Now we're going to start talking about aggregates. That's where my screen turns back on. In just a minute. I'm going to do a few demos with the aggregates. And I bet you I'm not even on the camera right now. Oh, I still am. God damn. But that's not on the camera. Let's go and say. Before I erase that board, so somebody who's not here can see what I wrote over there. Okay, now we're coming back this way. All right, so the last little bit is I'm going to talk about aggregates before I start to go into demo time. Aggregates are used to summarize data. Use them to add up values. Common aggregates. Sum, count, average, min, max. Those are the most common ones you'll see. There's also deviation and mean. That's another one that you'll see. Those are the common ones that most people use. Now, there's two kinds of situations when you get an aggregate. When you get one value back, that's known as a scalar. It's a scalar aggregate. In other words, if you, for example, if you do a count star and you don't have a group by, it returns one value. That one value is known as a scalar. If it returns a list of values, it's known as a vector. They're important terminology to remember, so I've been told. Just putting it out there. I didn't even know, I hadn't heard these phrases in 20 years. But apparently they're in the textbook, so they're important to get covered. If you're looking for it, it's a little a side note, little footnote partway through a chapter, chapter 6, with a definition next to it. Okay. These are the common aggregates. What I'm going to do now is I'm going to actually erase this in just a moment because I want to keep the screen lit so I can write on the board behind me when I start typing stuff in. That. And I'm going to do my transition. This guy up here. Projector on. Lights out. Shim on. Maybe. Over there. Over there. We've got a winner. Okay. Oh, so much glare. All right. No, that's not so attaching the whole screen. There we go. Okay. Go this way. Grab this. Bring it down. Just like that. Good enough. There. Anyways, if anyone's watching the recording, there's a big, fat, bright white circle right here. In the future, if you go watch this, there'll be a big glare right there. Nothing I can do about it. Okay, aggregates. Okay, select count. That's basically your normal count aggregate. It's used to count how many things get returned. Now, that's a scalar, one value. However, if I were to do group by city, this is a vector. So now you have a visual example of the difference between the two. Can you aggregate an aggregate?
Sure. Yeah.
You want to bet some pizza on that?
If you're buying.
No, I'm not, because I know I'm right. So I'm going to say I want the average count of people per city, right? No, you can't. You're not allowed to do that. You can't do it because the way it works is it retrieves all the records, counts as it goes. Once it's done, you're asking it to now do that a second time with data that no longer exists. So you can't aggregate an aggregate. I'll show you guys how to do it in a few minutes. There is a way of doing it, but that's not how you do it. Okay. So this you've probably seen by now, I hope. Have you seen aggregates yet in lab? Sort of, maybe a little bit. Okay, so that's a count. If I were going to go, I'm going to switch this down to order lines. And I'm going to go the sum. By the way, you can't sum everything. You got to sum a specific. And I'm going to put down the order ID. I'm going to run this. Okay. Now for me to draw on the board a little bit. So We have order IDs here, and we have sums. Okay? Now, this, we know what this is. This is our aggregate. Our group by clause the group by clause creates categories. That's essentially its purpose in life. It creates categories. And in this case, it's creating categories broken down by order ID. So essentially, it's going to add up all the extended prices, and it's going to break it down by order ID so we can get a total for each order based on the order lines. So that's the basic parts of an aggregate query. However, there is one more clause we can throw on this. Now you guys know how the where clause works so far, right? Where this. Have they talked to you about having? No. There we go, something new for you guys. I knew I was going to get to the point. My guys haven't seen having yet. They're getting it Monday. Having. Having is similar to where. But its purpose in life is to exclude based on the results of an aggregate. I was about to start writing on the board and pretend I was actually going to execute. Right, we go, if I can go having, and if I type the word having properly, sum of extended price, and I can say I want all the ones that are more than $250. So when this ran, and we can't see what the bottom edge of that window has, because that'd be too much to ask for. Make it a little smaller and bring it up. So 43,000 rows got returned. Now I'm going to say, give me everything that has a halving greater than that. So if I go, bang. So now I got 30,000 rows and change came back. Why? Because I excluded everything that was less than $250 order. That's what the having clause does. It allows you, after you've summarized the data, to exclude stuff you don't want. There's a few other things you could do in here. You can actually do aggregates that aren't being displayed. If I want to do something like actually, I don't know if this is actually going to work. It worked. Okay. I haven't done this in a little bit, so I was a little leery. What I just did is I said, okay, I want the sum of any order that has more than 3 things in it. So this shows that the having clause is not dependent on the actual aggregate. It just allows you to exclude based on an aggregate. Oh yeah, of course, now everything doesn't line up on the back. Hold on. Okay. The having clause okay, the having clause excludes based on an aggregate function. Okay. Any questions about the having clause? I mean, it's pretty straightforward. It behaves just like a where, except you have to use an aggregate inside of it. Yeah? It will not work in a where, because what happens is the where happens before the counting does. So essentially what happens is it retrieves the records, the where filters it, Then the aggregate runs on the filtered results. Then you use the halving to cut out the filtered result. And then, of course, there's one last piece that happens, and it's good old order by, which, you know, by now you guys probably know what order by does. It sorts your results. Earlier when I was talking about the stuff that happens after the wear, I just remembered there's one last bit that I didn't cover and I forgot to cover, and that's how to handle dates. A lot of people get shot in the foot when they're working with dates because database servers are really, really literal. If you're working with just a date, no problem, right? A date is treated like a string, essentially. That's a date. This is the standard that's used in a lot of database servers. Year, month, day. That's pretty much the standard for dates almost everywhere except North America. Postgres is really flexible. You can actually put in the nice name, like you could literally put in January 1, 2016, it'll work. MySQL, you give it January 1, 2016, depends on what option they have in the INI file, it may or may not work. It goes. And then where it gets difficult is when you start working with timestamps. That's supposed to be a 6. Okay, so that's a date time, a timestamp or a date time. Depending on the database server, it has a different name. Postgres calls it a timestamp. MySQL calls it a date time. Other ones, Microsoft SQL server calls it a date time. But essentially, it's the date with the time. What a lot of people don't understand is when you look for something that's called, when it's a date time field, and you say, I want. Say we have a few called ordered. And I want everything that was ordered on this day. So if I did ordered is equal to this, and you might end up with no results, even though I have an order. Why? Because it always assumes if you're working with a date time field and you go equal to a date, it assumes midnight. Literally 0. The moment of 0. And is this equal to the moment of 0? No. So you end up getting bit in the butt when you're trying to find something for a specific date if it includes a timestamp. Just so you should be aware. Because if you said, give me everything like this, less than or equal to January 1st, and you literally wanted to include January 1st, you wouldn't get this record. Why? Because it's not midnight. Because it assumes, if it's a date time field, that the time is set to 0. Therefore, this is not 0. Anything on that date will be ignored after the very second of 0. And I can guarantee that that actually doesn't exist. Why? Because Postgres tracks transactions down to the microsecond, right? 5 digits of precision past the second. There's always more than 0. So there's 2 ways to handle this. Well, there's 3 ways to handle this, I should say. And by the way, if you use between and you put this as your end cap, it still treats it as midnight. So between will still not include anything on that date. So there's three ways of handling it. Option number one is you add 1 day. So you say less than or equal to the, instead of saying the first, you make it less than or equal to. Or you can just say less than that, obviously. And therefore, it'll grab everything in that date from 000 down to 235959 dot 99999. That's one way of grabbing that date. The other way is, I'll ask this question and I know what the answer is going to be. Have you ever heard of casting a data type? Yes. Oh, that's the first time I've heard a yes when I asked a programming question so far this term. The other choice you have is to cast the date time as a date. What happens then? The server cuts off the time and therefore you're only working with the part of the date. So there's two ways of doing it in Postgres, and MySQL does it different. I'm not even going to put the syntax on the board because there's so many different ways of doing it. But option number two, so that's option number one. Option number two is cast to date. Option number three, you can explode the date into its component pieces. And again, every server has a slightly different syntax, but you do something like this. Date part, and you give it whatever the field would be, right, that'd be ordered. Then you say I want the year, and you want the month, and the day. And in here you put in what you're trying to target. 2016, 01, 01. Now this seems really contrived and overly complicated. However, it has one big advantage. Let's say you want everything that happened in January. You can just ignore the last bit. So instead of saying, give me everything that is greater than or equal to like this, and less than 2016 0201, you can just say, give me the date part where it's 01, so it'll search here instead. Therefore, you can do a very targeted, and it's actually really handy when you're handling, I don't know, leap years. When, February has 28 days, 29 days, and I think in about 10 years, for the first time in hundreds of years, 30 days. There's a big correction. They call it big correction coming. Computers are going to shit themselves when it happens. It's true. I mean, the Y2K was horrifying, those of us that lived in the IT industry while we went through it. The amount of overtime we put in the 3 weeks before it was terrible. For nothing. Nothing happened. I did my job right. My wife was happy when I was sitting at Compaq, New Year's Eve. I had to live in the 5 to 12, waiting for the database server to crash. And nothing happened. I went from there and went home and had beer till like 5 in the morning. But just saying, there's a big correction coming also. So if you use this technique, it avoids things like leap years, odd months, avoids dates and times because you're extracting a piece. You can actually use that technique to say, I want to know all the totals that happen at 3 o'clock in the afternoon. Or you could theoretically group by the date part of the day if you wanted to. So that way you can actually get stats broken down on a per hour basis. On a per day basis, you can see which day of the month you sell most stuff on based on grouping by the date part. Kind of cool. So date part lets you extract that. All right, that was the little bit of lecture I forgot to do earlier before the break. Okay. That's my Blackburn. Doing subqueries next. Did you guys see anything about subqueries yet in any of your labs? I got one head nodding. I don't know if they're nodding to me or they're nodding to the computer, but you know. Subqueries. Now, subqueries is a query that's run as part of another query. That I think you should know if you've seen it in your lab. Now, I don't know what they covered in your lab. Did they cover the 3 places subquery can be run? Actually, in 4 places. It can be run in 4 places.
Not explicitly.
Not explicitly. Okay. You can run a subquery in any of those 3 places. When it's part of the select statement, it's designed to be a scalar. You are trying to return one value. It's often used when you're pre-populating data from somewhere else. So you need to know what the default ID is of the record that has a name of new. And you don't know what it is. Therefore, you could actually create a select statement that actually pre-populates that value. I'm going to skip the from for a moment. Where? This is probably where you guys saw it used most, right? You're using it to build a list for the imp clause. Essentially, you're building a list and you're comparing it against that list. You can use it as part of the having. Used the exact same way as the where. So you can use it as the other side of the operator in the having. From. That's where the magic sauce is. The from, when you use a subquery in a from, it's known as a derived table. All right, so when you do this one I'm actually going to demonstrate is using it in all the different little spots. It's known as a derived table. What it does is it creates a table in memory, temporary virtual table, let's say, in memory. And for all intents and purposes, it behaves just like a normal table. It doesn't have a primary key and it doesn't have any indexes, but it behaves like a normal table. You can do joins on it, you can include in where clause. There's one catch, it has to have an alias. Otherwise, the database server does not know what it's called. Okay. I'll be demonstrating this behavior mostly. So I'm going to do my, my demo on this really quick. Because you guys have already seen some of this, so I can actually skip a tiny bit of it. Okay. Remember earlier how I promised that I'd show you how to aggregate an aggregate? So one of the common questions, I'm waiting for the projector. Oh, winner. Okay. One of the common questions I get at work is, what was the average sale that came out of our e-store last month? That's an easy one to figure out, right? You just go average total. But what happens if it's a shopping cart, like the one we use, which is a little special? where it doesn't store an order total as part of the order, because it's not a cart designed for high volume, thus it doesn't store any derived values. Therefore, I need to aggregate an aggregate. I got to add up all the order lines, excuse me, then I got to find the average. This I showed you already how to do, right? How to sum up each of the order lines. But here's where the magic for the derived table comes in. There, I'll call it D table. And I'm going to run it. And the result's exactly the same. Except one thing just happened. The server ran this query first, took the values, stored them in memory, and then ran the outside query against it. Which now I can now do. There's one issue though. As you notice here, it's coming out as the word sum. We need to give an alias to our aggregate. I'll call it order total. So as you can see in here, if I run just this, it looks like that. If I run the whole thing, if I actually click on the right screen, it looks exact same. Do you notice it's a little slower? There's a little pause. It has to think a little harder. What it's doing is it's actually doing all the stuff in memory, creating the temporary table, then it runs against that temporary table. If I were to run the planner against it, it shows the query that was run, and here's the explain. Well, I want this. I hit the wrong button. Explain it. Where's the explain button? I was still trying to figure it out. That's nice. All right. That's the one. It scans the order lines, it creates that stuff in memory, and then it aggregates. Whereas if I were to run just this one, that's actually going to do the same damn thing to me. Go figure. If the server's clever, it's caching the results now. So it's making a liar out of me. All right, so earlier I was promising I was going to show you how to figure out the aggregate. If I were to go to the average of the order total, there's my average. I just aggregated an aggregate. This is useful because it gives me a benchmark. And it's a fairly okay benchmark, to say the least. Now, I'm going to make this significantly more complicated for a read, just because I can, actually. This is where I'm going to show you guys the same query I did to my poor suckers on Monday. Okay, so what I want to do is I want to figure out which orders have, what's the word I'm looking for? Which orders are larger than the average. So I want to target the customers that have a larger than average order. And it gets a little special at this point. Because what happens is we need to have an aggregate and we need to have a subquery that's part of the where clause also. Oops, I clicked on the wrong screen. I got my example up on the other screen, on my my window here. All right, here we go. If I grab I'm going to start another table. I'm going to go, actually, I'm going to grab this. Like that. Did I get it right? Oh, I got it right. Okay, let me explain what's actually happening in here. This, that's A. That's this bracket. Okay, good. I just got to find my brackets here. Okay, I'm going to put up the screen so I can actually start writing on the board. I should have erased this. Okay, here's the bits and pieces of what's happening in here. This is probably not the worst query you'll ever see in your life, but it's a fairly complex query. Actually, I'm missing a little bit of it. Okay, that's the whole thing. All right, so how many subqueries we have going here? We have one. That's one. We have two. And then we have three subqueries happening all at the same time. So essentially what's going to happen is this I showed you just wrong color marker. Right? Here we're getting the sum. And you notice? I actually can't even read that. Sum. And this is exactly the same here. We're doing the sum up here. And here I'm doing the average. So far, so good. This is what I showed you guys just a minute ago. Nothing new. However, up here, what we've got is we do select star from, and we got our sum query once again, and this time I derived it as A. And we go where the sum of order, right here, this one here, right, this guy, is greater than or equal to what comes out of this. So what I'm doing is I'm figuring out the average order total with these two subqueries that are nested, and then I'm actually extracting the comparison here. It looks bad, but it actually makes sense when you think it through. When you assemble it piece by piece, you don't start writing these the first time you start writing subqueries. But essentially, it's in logical chunks. We want to grab the sum, but we actually want the average, so we've got to average the sum. Okay, so that's our first piece, and we know we still want to deal with the sum, so we just literally took this and put it up here. And then we just add a where clause, and we're putting this in the where. Theoretically, we could do this with, we could actually do it with here, and having a halving instead down here. And we'd embed all of this all over again in the halving. And you'd need some extra stuff, because right now with the average, we'd have the order total IDs coming out and stuff like that. It'd be kind of gross. I will post this eventually with comments next to it. But that's how you exploit the subquery business. So this has a subquery as part of the where clause, as a derived table, twice. I'm actually not including a scalar subquery up here because those are such an edge case that you normally wouldn't. Okay. Now on to the last bit for you guys tonight. Then those of you that don't need to stick around won't need to stick around. Okay, put this down. All the way down. Okay. I know you guys got your own screen over here, but I'm over here, so. the joy that is assignment 2. This is the same assignment 2 my guys have. So I tried to find something that was somewhere in between what both groups would be at. Right. The first part is a tote diagram that looks like crap. Those of you that have looked at it already know it looks like complete garbage. It was done like that on purpose. Otherwise, it wouldn't be an assignment. What you're going to do is you're going to take that piece of crap diagram, you're going to fix it. And you're going to follow the naming conventions as listed here. Fair enough? And you are going to recreate the tables as needed to fix it. Essentially, so you know what the purpose of that database is an email campaign tracker. Super simplified. How many of you get spam? All of us. If you don't get spam, you're not on the internet. You haven't bought anything, you haven't signed up for anything, you don't have Facebook. Right? You have nothing. Often, they run campaigns where they send out mailers. So what happens is they collect all the email addresses, they get put in a bin. Then they create a campaign, which has a message and a target date and wants you to be sent. And then they assign a subset of the email addresses to a campaign. And then there's a log. Campaign ran. This email address received this campaign. That's what the purpose of this is. So you have the verbal description of what it actually is. Based on the diagram, you look at it, you go, I can't even figure out what half this stuff's supposed to do. I just describe to you what it is. Part 2. All right. I know you're going to clean it up. That's the first 5 points. 5 points for naming conventions and or proper relationships. And I murder on naming conventions, just so you know. Every time you violate one, I take 1 point off. It's not half points, quarter points. Every time you don't have a primary key called ID, -1. If I see camel case, -1 for every time I see the camel case. I lived this, having to change my naming convention habits. When I changed jobs a few years ago, where his naming conventions were the opposite of my old ones. And every week he gave me a piece of his mind about the naming conventions. This is actually giving you guys a chance to let your brains be flexible enough to adapt to a different naming convention. Okay, 1 point for naming the file correctly. Believe it or not, I care, because I've received this before where all it said was assignment 2, task 1.png, no name. 3 people gave me the same file. Guess what happened? I only graded 1 of the 3. Why? The last one alphabetically, because that's the one that got overridden. I didn't know which one was which. I actually had to go crawl through Blackboard afterwards to go find which one didn't get a grade. Then I have to guess whether or not I got the right person. So this is, I give you a point for free for saving me effort. Part 2. Part 2 is a quiz. Ish. Using the ThinkCube database, I'm not putting up the questions on the board. This just now shows up. You guys can probably look at it if you click. You are asked, I think, 10 questions off the top of my head. Coming out of the ThinkCube database, might be more than 10 now. I think I added a few just to make it a little harder. And you will answer the question. I don't want the SQL. I don't care how you get the answer out of the database. If you do it as 6 queries, knock yourself out. If you do it as 1, that's fantastic. It asks you a question and you give it a word or a number. It tells you. Is it going to be I'll put up. Okay. How many employees are there? That's a number, right? How many customers have this starting with JA? And in here, if it needs to be more precise, I'll tell you, it's a number rounded to 2 decimal places. Either use the rounding functions built into the database, which is, a function called round. If you don't know how to use it, look it up. It's not hard. You Google SQL or PostgreSQL round function. And it cares about whether or not your rounding is correct. So you want to round it properly. This is your prep. It's an assignment that doubles up as your preparation for your practical exam. The practical exam is done in the lab. It's going to be 2 hours long, because that's how about an hour 50 minutes long, because that's how long the lab period is. It's the same format as this. The big difference is the questions come out of a random pool. That means that 3 of you can be sitting side by side and you'll have 3 different exams. Yes?
So it's going to be open textbook?
It's open book. I'll leave instructions with Kumar and Howard. If she sees one of you going, you get 0. Because that's cheating. You're not allowed to help each other. It is to be done in lab, in the class, at the time assigned. I'm still trying to figure out how to wire that down a little bit, because I've had to change the practical exam this term a little bit, because the old one was crushingly difficult, but it was a take-home. As in, it was known to take anywhere from 3 to 18 hours to complete, but you had 6 days to do it. I'm just telling you, the guy the fastest it was ever done was 2.5 hours. He got the same score as the guy who took 18 hours. And I can guarantee neither of them did very well. The average success time is about 5 hours for my old practical exam. This one here is about half the number of questions. And they're not going to be as difficult. So the way it's going to be set up is there's a couple of easy questions, a couple of average questions, and usually one mind-numbingly painful question at the end. It's not going to be that mind-numbingly painful, but it is going to be, compared to, how many customers have, how many employees there are, that'd be like easy. Okay? What is total extended price for largest order? Shit, I just hit that on the board. That's great. This is, actually I didn't do that on the board, but this would fall into the medium category. This is, also towards the top edge of the medium, just so you know. And it's not going to be a thick cube database. It's you're getting this database, you're coming into it cold. The point of it is, can you read the diagram and understand the structure? That's what makes a practical exam hard. You come in cold. So you guys have restored databases, right? That was one of the labs you guys were supposed to do. You restored ThinkCube, same instructions. I'll even have listed instructions on how to restore it. So that's the preparation for that. So this assignment's your prep for the practical. And I think that's it, folks. And if anybody has a question for me related to the lecture, no? Silence? Good. I'm going to hit the stop so I can talk just for a second more.